And
Okay, we are live.
okay, yeah. So mostly just been thinning the forest. So cutting down a lot of the same trees to clear out space for diversity.
Right.
And so, I cut down fir trees because we got a million of those, but then I
Yeah.
leave hemlocks and maples and stuff that are a lot more rare. Um, and but it's so physical, and
Yeah.
I'm just sore today. Like I put in a big day yesterday, and I'm just so like my hands are sore
Yeah.
from like holding the like I'm using an axe. My shoulders are sore from carrying a chainsaw. My legs are sore from tromping around in the forest, but
Oh
but
man.
the forest is greatly improved. Yeah, yeah. You think a forest would be able to just like do its own thing and just
No.
be what it
You
wants to
can't
be, but
trust those
no,
trees.
no, no, no.
Trees
They
are not to
left
be
to their own
trusted.
devices. No, they just make a stupid forest. I need to make a better forest. Um, I mean, obviously, I'm fixing the horrible mistake from a rapacious logging company, as opposed
Yeah.
to try to improve on Mother Nature's design. So, oh man. So did you see we posted the 200th question show event
That is just
today?
awesome.
Yeah,
And
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 so
the
oh, go
thing that
ahead.
gets me about question shows is you'd think that and by and large, it's the same 10 questions that get asked over and over and over. But then
Yeah.
there's like three new ones that get asked every time you ask for questions. And you have mastered the finding the questions that are new and unique and answering them.
Hmm. Yeah, I mean the joke I made is that half the questions have been about Lagrange points, but the other half have been interesting. But it was great because I passed along the questions to a whole bunch of other space YouTubers. So
Yeah.
I leading up to the question show, I asked for people for just murderous, brutal questions, and the sort of surprise. I'm not going to answer them. I'm going to let Scott Manley answer them. But it was a lot of fun. And it was wonderful just to see the response of all these other people. I mean, they're all friends, right? It's
Yeah.
so great to see this wonderful community. And also, they're all such pros, and so everyone's
Yes.
audio was great, everybody's video was great, everybody's answer was great, and so it was a lot of fun. Yeah.
Do you ever get asked to give talks for astronomy clubs and then become deeply confused when they're like, we need to do a tech check and make sure you understand how to use Zoom and
Yeah, yeah, yeah,
make
yeah.
and it's just sort of like I I don't understand.
Yeah, yeah. Don't worry, I got the tech. Sure, but
Yeah.
whatever. If you want to test my technology, let's do it. Yeah,
Yeah.
yeah. But I got it. I got it under control.
So
I could
today's episode is 660?
661.
Dang, okay. I missed
Yeah.
a week. The numbers just keep growing.
So I've got to go. I've got a meeting at exactly 12 o'clock my time. So I've got to go
Okay.
about 5 minutes early just to make sure that I can transition over into that meeting. So
Okay,
that
that
is
works. I had to
okay.
turn off my heater so we'd get clean audio. And so
It's
ending
just going to get
early
colder
means
and
I can
colder.
turn the heater back on.
That's funny.
Okay.
5 episodes to go for 666. What could we do for like horror, scary things in the universe? What would be like a cool 666
I need to look up what Dante's
reference?
seven levels of hell are
Ooh,
because
yeah.
I know there's the ice and there's the hot. And so we can do like we can there's literature people out there, they will help me.
I mean, that would be a little too on the nose, you know?
Yeah, but
But I'm sort of thinking just kind of like scary,
okay.
eldritch horror. Like, let's take a Lovecraftian perspective on it.
Everything that Judy Schmidt has processed from the Hubble, or not from the Hubble, from the JWST.
Yeah. 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 Exactly. Yeah. 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 All right, let's get started. Let me know when you're ready.
All right, I am pressing that record button. I am pressing that record button. It has said there is a problem. Why do you think there's a problem?
I don't know.
I don't know either.
Do you need to start again?
No, I need to tell it to use the correct microphone.
Okay, I'm going to stop my recording. Tell me when you're ready.
I am pressing record again, and this time, it is recording.
Good. Excellent. Here we go. Astronomy Cast, episode 661, Canceled Missions. Welcome to Astronomy Cast, our weekly facts-based
I
journey
wasn't doing canceled. I was doing they died. So
What?
not just canceled, because like Insight isn't so much canceling as dying. Sophia was canceled. You got me there.
Okay.
We're saying goodbye.
The missions that ended. All right. Saying goodbye to ended missions. All right, I'll change that.
Sorry.
That's fine. I can
Sorry,
do it.
everyone.
Okay. I'm not sorry.
I am. I was unclear. I'm going to stop the recording.
Okay. All right, so I'm gonna. So I think my subject, that my idea for this episode is good and still valid. Then, so here's my intro. Is several productive missions are about to be turned off forever. How do space agencies decide which missions need to be shut down, and why do others just go on forever? And so you can talk about ongoing budgets and talk about decisions made like Sophia, things like that, shut down missions. So maybe we can think about that in the future, like why cancel a mission.
Yes, all of that is a completely excellent show. It's just
not
I was prepared to say goodbye to some of the Voyager instruments and to Insight and Sophia and have much more of a end of year kind of we loved them and we lost them kind of.
Give me a second. All right, so again, ready to press record?
Yes. Buttons. Pressed that one. We are recording.
Astronomy Cast, episode 661, Saying Goodbye to Missions That Ended. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years. With me is Dr. Pamela Gay, senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. It is solidly winter here, which means we have gone from the part of the year where I have to turn off the air conditioning to record to the part of the year where I have to turn off the heat to record. And what I've realized is there's a lot of thermodynamic suffering that takes place for this podcast.
Yeah, we're like at the end of a really nice stretch of weather, and it's about to get cold and snowy, and I am nervous because the only person who handles snow plowing on our mountain hill has decided he doesn't want to do it anymore. So I'm not really sure how we'll escape our house. Anyway, let's get on with the show. It's always sad to say goodbye, but when we send our robotic emissaries out into the cosmos, it's just a matter of time before they shut down. Today, we're going to say goodbye to a few missions which have reached the end of their lives, but they were very good robots. All right, Pamela. Well, actually, and we'll talk about it in a second, but it's time for a break. And we're back. All right, let's talk about some robots that are about to just turn into chunks of metal.
Well, they were always just chunks of metal. They were just slightly more animated chunks of metal in the past.
Smarter metal.
Smarter metal,
Yeah.
yes.
Yeah. More mobile metal. Yeah.
So, my favorite Mars mission, and I never thought I would have a favorite Mars mission. My favorite Mars mission, InSight, is estimated to cease to function in a meaningful way sometime this month as dust builds up on its solar panels, and they're trying to measure every last possible earthquake they can. But its time is coming, and it's a good time to look back on what has become one of the most creatively engineered midstream along the way mission that we have so far sent to Mars.
So now, I mean, it's Mars InSight is solar powered.
Yes.
So why is it coming to an end? The sun's still there.
The sun is still there. The problem is that dust has a habit of building up between the solar panel and the sun and limiting just how much sunlight is able to get to those photovoltaic cells and power the systems, including the heaters that are needed to keep it going over time.
But wait, NASA is aware of dust. Why didn't they think of a way to remove the dust from the spacecraft?
I know, this is the constant question. And the
It's
issue
like half the comments that I get on my videos.
I know. And
Yeah.
and what I love is this is the first mission that has gone out of its way to try and remove dust from its own solar panels. They scooped up a scoopful of sand and used it to essentially remove the dust from the solar panels. But they don't have a lot of electricity.
Yeah, that method though. I just want to talk about that method. So what they figured out, like normally, right, the rovers have their solar panels dusted off by dust devils, but for some weird freak of Martian weather, the place where InSight went hasn't been getting visited by dust devils. And so they figured out this really clever way where they scoop regolith with the little shovel, they dump it on the solar panels, and the dirt collects up this electrostatically charged dust and drags a bunch of it off. And they dramatically extended the life of the rover using this technique that nobody knew it was even possible, which is wonderful.
And this is one of those things where they weren't able to keep going with all the instrumentation. But the thermal sensor they had decided long ago that it was not going to be cooperative anyways. And so as they prolonged the mission, they simply said, we're going to let that one go. So to go back to the beginning, this little spacecraft landed back in 2018. It had two primary instrumentation sets. It had the seismograph and it had the mole. And the mole's goal was to drive itself down through the dirt on the surface, embed itself a couple of meters under the ground along the way, measure the thermal properties, and allow us to finally know if all of our models for how the temperature varies as a function of depth on Mars are accurate or not. Mm-hmm. And what we learned was the dirt on Mars is more clay-like than we had anticipated. And the mole did not dig. They tried everything.
Bounced. Yeah. Yeah. I have very clay soil where I am. And when it dries out, it is concrete. And obviously, regolith on Mars has dried out.
And the way the mole was supposed to work is it was a long cylinder that had essentially a thumper, just like out of the movie Dune, embedded inside, and it would slowly rise up and then smash down. And the smash down was supposed to drive the entire thing downward through the soil. And it just kind of stayed in place. They tried pushing it down with that wonderful arm. It refused to go. So we didn't learn anything about the thermal profile, but the creative solutions, they just kept trying until senior review said, stop, just stop. Were truly delightful. The other instrument was a seismograph that was designed to measure Mars quakes, and they weren't sure what they would detect when they built this instrument. They figured if nothing else, they would catch the waves of space rocks, asteroids, hitting the surface of Mars and sending shockwaves reverberating through the planet. And what they found instead was Mars is continuing to have quakes. It has a over 1,000 kilometer across a molten core that is a lower density than had previously been estimated, and that lower density is responsible for completely different thermodynamics than what had been predicted, allowing it to continue to have this molten core far longer than we had thought possible. Its surface crust is thinner than we thought, and we learned all of this because the planet periodically just has Mars quakes.
Yeah.
And we've been measuring them, and a bunch of them are located with the same geographic region. And so this world is a whole lot more interesting than we had thought. And we now need more seismographs, please.
Everywhere.
Yes, please.
Seismographs everywhere. Yeah.
Yes.
Yeah. And, I facetiously asked the question about the Mars dust, but the answer is fairly simple. The spacecraft was designed for 1 year.
Mm-hmm.
And so they gave it this solar power capacity for 1 year, and it ended up lasting 4 years, way beyond what it was expected to. And could there be a system, some kind of mechanism that dusts or blows or wipes or cleans or electrostatically charges or scrapes dust off? Maybe, but each one of these devices adds to the weight, adds to the budget. And how they were given a set budget to work with, and they designed all of their science goals within that set budget, and they launched their mission. So, but on that note, actually, NASA is developing a really interesting sort of coating that they can put on everything that is clear, that is electrostatically charged, so that you can, or it can be electrostatically charged, so you can actually run a current through it and repel things like the dust. Because like the stuff on Mars, it's like, imagine like, when you open up a package and you get the little styrofoam,
The little white beads.
Yeah, the little styrofoam beads that just cling to everything. You try to wipe them off, and now they're all in your hands, and then you wipe them against something, and now they're over that, right? Like, it's the electricity that's holding them. Anyway, so they've developed this new coating, and they're testing it on the International Space Station right now. It's actually on the exterior. They have a bunch of experiments on the exterior of the station, and they will, if this works, then they can apply it to solar panels, to camera systems, to science instruments, to anything. And so just like by default, any new rover will be equipped with this coating, and then all of these surfaces they can run charge through them whenever they want to try and repel the stuff. So my point is like NASA's aware that there's dust, and they've thought of ideas, and they've had to reject all of them. And if you were in their meetings, you would have too. All right, we're going to talk about another mission that we're going to say goodbye to in a second, but it's time for another break. And we're back. All right, what mission do you want to say goodbye to next?
So the Sophia Airborne Observatory, I think is one that will eventually deserve its entire own show. But they only did its last flight in September of this year, 2022. And we're still waiting for all of its, latest round of data to get its first round of processing. So that highlights episode will have to come in the future. But for now, we have to say goodbye.
So what was Sophia?
So Sophia was the I
Spheric?
can never say this. I have to look at the word to be able to say it. I am sorry, everyone. You're slowly learning. I truly cannot pronounce anything. Okay. So Sophia is the Stratospheric Observatory for Infrared Astronomy. It's a modified 747 that has a over 2-meter telescope just kind of hanging out in the back with a door that they can open and point the telescope out, allowing them to, as they fly through up to 10 hours worth of night, allow them to observe the infrared sky in colors that we can't see even from our highest mountains, because they're able with the aircraft to get up above the worst of the water. Sophia flies up at 41,000 feet. So this is higher than your standard 747 on a consumer flight. And this specially designed observatory, it had vibration compensators. It had some of the coolest technology, literally, because it's infrared, you have to have cool technology, of our time, allowing it to do everything from, I think one of the most surprising, and we covered this earlier, discoveries was they directly measured water vapor on the moon. That was
not water vapor. They water in the regolith.
You're right. I said that wrong.
When you think about water vapor, it's like,
Yeah, no, that would have been, yes, sorry, my bad. They directly measured water in the regolith, being able to see that it was in places that it hadn't been anticipated previously. They were able to see helium hydride, which was a molecule that it was expected that it existed in the early universe, but we hadn't seen it prior to Sophia spotting it in a planetary nebula. This is one of the few molecules that helium is willing to be a part of, where basically a proton, a rogue hydrogen core, is able to share an electron with a helium atom. Over and over, this telescope allowed us to see wavelengths that otherwise required a spacecraft, but using instrumentation that got to be brought home at the end of the flight and modified and improved and constantly changed as our technology changed. And it was this fabulous hybrid between a ground-based facility with all of its atmospheric limitations and a space-based observatory with all of its lack of modification limitations.
So why are they shutting this down? I mean, it's not like its solar panels are getting covered with dust.
Yeah, this is the great question. It basically comes down to NASA only has so much money to run all of the observatories at any given moment, and JWST is the great sink of infrared funding right now. So with JWST fully functional, the argument was made that we don't need a 2.5 meter telescope pointing out the side of an aircraft when we have this significantly larger telescope sitting out at L2. And
like James Webb completely overlaps the capability of Sophia, except that Sophia can look at the moon. JWST can't look at the moon. But apart from that, and JWST could make the observations that Sophia might make in an evening's, in one flight, it could probably make that in a fraction of the time. It's more powerful. It's out in space.
Yes, but Sophia lets you continue to innovate and test new technologies.
Right. And
It's
that is
useful.
huge.
Yeah,
Yeah.
we need to be able to experiment, and I've brought this up before. I am very much a fan of design and test, and just keep moving with incremental design. JWST, SLS, these are all, it works or it doesn't, kind of all or
Yeah.
nothing. And I
Yeah.
don't like
But
that.
that's the programmer in you, though, right? Like
It's
that process of iterative development and design is baked right into creating something
yes.
that is complicated. And I 100% agree with you. I mean, there is another track where this stuff gets built and designed and tested, and that's balloons. So
Yes.
NASA still has a very vibrant balloon astronomy pathway. We actually just did an article on Universe Today about all of the cool balloon missions coming up in the next 10 years. So they're putting a lot of investment into developing new instruments, putting them on balloons, flying them at high altitude, and they can go way higher than Sophia can,
Yes.
testing out to see whether they work, iterate, and then these things start to show up on spacecraft down the road. So I do think that there is another pathway. And so I guess that's probably it, is that in terms of pure productivity, Sophia just doesn't hold a candle to JWST. You are burning jet fuel. You are contributing to climate emissions. You are, right. There are downsides
Yes.
of running a 747 for 15 hours, and then all the other ongoing expenses. So it just sounds like somebody just said, "Well, I think it's time to shut this thing down." And it is unfortunate because it's a wonderful, glorious instrument and such a great idea, and has produced so many wonderful findings, and yet it's just like the landscape has changed.
I do wish that they allowed it to stay commissioned, kind of like old Ironsides in Boston, one of the old tall ships stayed commissioned, where no one expects old Ironsides to sail out into battle anymore. But to have it to continue doing its teacher programs and to still be there if it's ever needed to fly once again.
If there's an asteroid passing in between the Earth and the
Yes.
Moon, and J. Davis, you just can't watch it, and then you can get Bruce Willis to fly Sophia. Yeah. All right, we're gonna talk about another mission that you're sad to see go in a second, but it's time for another break, and we're back. All right, what else would you like to say goodbye to?
So Voyager is shutting down.
No, don't say it. Voyager's fine. It'll live forever.
Voyager will live forever. This is entirely true.
In that the physical atoms will exist in some kind of coherent form for a few billion years, sure.
And come back. I'm trying to figure out how to make a good pun.
You're trying to make a Star Trek reference?
I was trying to make a Star Trek reference.
It'll
failed.
It'll find an alien intelligence, merge consciousness, return to Earth, and search for whales? No, wait. Now I'm starting to blend my sci-fi references. All right. But tell us about what is the state of the Voyagers? Because I feel like I've been bracing for impact for the loss of the Voyagers for about a decade now.
So Voyager 1 and Voyager 2 are thought to have finally, actually, this time for real, have left our solar system's sun interacting environment and are on their way beyond it. Now, they're still within the confines of the Oort cloud. Our solar system really feels like it goes on forever, but they have exited the area that is defined by the sun's influence, and they are now able to experience the cosmic rays at the higher level, to experience the interstellar conditions better. And they were sending data back, and they continue to try to send data back, but it reached the point where they did have to turn off more instruments. And I think what was more of it's time to start to say goodbye than just shutting down more instruments, because they've been doing that on a regular basis pretty much as long as we've been alive.
Yes.
The real thing was Edward Stone, the project scientist, retired after 50 years.
Yeah.
And right now, what we're seeing isn't so much in planetary science the retirement of the Apollo era folks, because that's rocketry. Yes, we have a few of them. Harrison Schmitt still attends meetings. There's no greater way to confuse the speaker than to start your question with Harrison Schmitt, Apollo program. That is what causes speakers to tremble.
Yeah, Buzz Aldrin.
Yeah,
Apollo.
well, he doesn't attend conferences and ask early career researchers questions the same way.
Right, yeah.
But
in the way that Dr. Harrison Schmitt does. Yeah.
But Edward Stone, he was part of this young group of researchers that didn't all even have advanced degrees as they were planning out exploration of our solar system. A lot of these people, they were basically making up what mission planning looked like as they went, because this was the first massive solar system exploration program we had, and it was put together on basically lack of computers to plan out the orbits.
I mean, think about the gravitational slingshot maneuvers they had to do to go past 4 planets by hand.
Rule.
Yeah. I mean, they must have used computers to some extent, but still, it was an astonishing piece of work to do that.
And so now we're starting to lose that first generation of real planetary scientists who planned out these missions and were there from day 0 to see the exploration of the outer solar system to, well, they missed Pluto the first round, but hey, that's what got us New Horizons. But the understanding that we got of Uranus and Neptune, Saturn and Jupiter, seeing Io's volcanism, the icy cracks of Europa for the first time, Titan's haze layers. We didn't understand prior to Voyager that all these moons of other worlds were worlds in their own right. And today we continue to see, I don't think kids are upset about Pluto and the definition of planet any longer, but planetary scientists really, really are.
Right.
The number of people that want to classify all the major satellites as planets in their own right is not trivial. And that fight was basically started by the Voyager missions. And I don't know what will end the fight, but...
Yeah. But it is different. Like when you think about the Voyagers, they've been shutting those instruments down one by one. And I think it's like when you care for somebody in your family, someone who is getting older, and you're sort of seeing this constant decline and it's happening in real time for you, as opposed to an accidental loss. The feelings of grief are different. And it definitely feels very similar to me. Obviously just a robot, but you feel, you're like, oh, it doesn't have now this many watts. Oh, it doesn't have the power to run that anymore. And that the last thing we'll hear, like the last instrument shut down, will be its ability to
communicate.
Yeah. And it'll all just be from declining power. Like all of the, like if you could replace its nuclear battery, it would be back up and operational. Probably. I mean, who knows how much damage is happening, but you could then send it to another planet and have it observe some more. But obviously there's no more other places for it to see. There's no interesting places for it to pass in the future. It's just going run out of power and go silent, and then drift in the Milky Way for another few billion years until cosmic radiation and space dust grind it away to nothing.
And it's estimated they will live to the 2030s, and beyond that, they just won't have the power to go on.
Yeah, we're within a decade of saying goodbye to them. All right. Well, we've reached the end of our show. Thank you, Pamela.
Thank you, Fraser. And thank you to all of you out there who make this show possible through your patronage at patreon.com/astronomycast. And we are starting with this episode to put out a ad-free version just for our Patreon community. So go check that out. Join us. And this week, I would like to thank in particular Smensky, Cami Vracian, Sean Martz, The Mysterious Mark, Glenn McDavid, Dwight Ilk, James Roger, Gabriel Galfin, Paul L. Hayden, Karthik Vekatraman, G-Force 184, Benjamin Davies, Planetar, Stephen Coffey, The Lonely Sand Person, Andrew Stevenson, Brian Kilby, Nyla, Arctic Fox, Bart Flaherty, The Air Major, Sam Brooks and his mom, John Osleff, Dean, Nate Detweiler, John Drake, Corrine Dumptruck, Lou Zealand, Jordan Truner, Lee Harbour, Jason Carducas, Ron Thorson, Paul Esposito, Arthur Latzhall, Frank Stewart, Ganesh Schwamathnathan, Bob Zatsky, Tim Garish, Ruben McCarthy, Robert Hundle, Kim Barron, Time Lord Iro, Daniel Donaldson, Ian Abdella, and Jeff McDonald. And if you want me to pronounce your name closer to true, please include a pronunciation guide. Otherwise, I'm just going to make it up.
All right. Thanks, everyone.
So much.
We'll see you next week. And then they saved.
I am terrible at pronouncing unknown words. Frighteningly, terribly, horrible.
Well, all you have to do is just become familiar with the naming conventions of people from every single part of the world.
No.
That's all. So it's tough. I mean, so like, if you grow up, like if you have some practice pronouncing Russian names.
Yeah.
Right. And I have some experience pronouncing French names. So it's just where we grew up and what, the kinds of names that we've heard before.
And I suffer from the problem that many people who read more than they talk suffer from, of lots of words exist in my brain as this series of letters with no pronunciation attached.
Mm-hmm.
And so I see them written out and I'm like, I know exactly what that means. And there are still cases I'm finding where the word I know from listening to the radio, from listening to audiobooks, and the word on the page have not become connected to one another in my brain. And I hope to someday outgrow that problem, but I'm almost 49, so I'm starting to lose faith. Yeah. I read a lot.
It is funny. Yeah, it's funny to sort of every now and then you say a word and I forget the most recent. You did this recently. There's some word, and I think I corrected you, maybe not. And it's just like, that's how you thought that word was pronounced. It's a thing. All right, let's get into some questions that people have. So Hal McKinney asks, what happens to JPL DSN communication frequencies used for retired missions? Are these frequencies shared across multiple active missions? Interesting.
I have no idea.
Yeah. I mean, I think it's more based on schedule than frequencies. But because if you can go to the Deep Space Network, the Deep Space Network are these giant satellite dishes that the NASA uses. They're positioned all around the world and allow them to communicate with all the spacecraft that are out there. And if you go to them, you can actually see which spacecraft the various mission the DSN is talking to
Yeah.
right now.
It's really cool. Eyes on the Sky, Deep Space Network.
Yeah, so let me see. Right now, in Madrid, they're talking to Juno, the Mars rover Artemis, and that's in Spain. And then at Goldstone, they're talking to CHDR, I don't know what that is, and Artemis. And then in Canberra, they're talking to ORX, I don't know what that is, and ACE. Are those CubeSats?
I don't know.
And then you
anymore.
can actually go. Oh, so STA. Oh, you can actually click on. Okay, so STA is stereo A. CUSP is the CubeSat for solar particles. MAVEN, the Korea Pathfinder lunar orbiter.
That's
Juno.
cool.
Yeah, and so they're you can get the distance, the transmission time, all of that. There you go. Oryx is OSIRIS-REx.
Oh,
So CHDR is Chandra. ACE is Artemis 1 as well. Oryx is OSIRIS-REx. No, ACE, sorry, is the Advanced Composition Explorer. Okay.
okay.
And then you can get, I believe you can get the frequency. So the Korea Pathfinder is communicating on 2.08 gigahertz, while Juno is at 7.15 gigahertz. So they're definitely very different transmission frequencies. And then Artemis is at 2.22. Stereo A is at 7.19, which is the same as, but that's a different dish.
Yeah.
So there's, I don't know how they do it. There's got to be somebody who allocates various frequency rates and times and which dishes are able to talk to them. It's fascinating to think, like, there's this whole infrastructure around planet Earth. You can see live views, the different. Maybe it's not live.
It's really cool.
No, they're not live. They're simulated versions of the different dishes and what their orientation is and what the light is like there.
You used to be able to click through to webcams on several of them. Do they not have that anymore?
No, I mean, it's all computer simulations of them right now that I'm seeing.
Okay, that's sad.
Yeah. And then you can see you can see what the spacecraft looks like. That's cool. This is really cool. And then you can see a map of the world where the different instruments are at. So cool. I don't know, but from what I can see right now, only one space. Well, so on Madrid at at Dish 53, you've got MAVEN, MSL, and MRO all communicating at the same time. But I'm wondering if they're going through MRO. Yeah, if they're combining their communications and retransmitting them through whoever has the biggest transmitter. So
yeah,
it is a fascinating rabbit hole. One that I, to be honest, have not gone down into, but it sort of sits. I should clearly do an interview with the director of the DSL because of the DSN, because it's like it's the forgotten half of this whole process.
Yeah.
And it's really neat. So thanks for the question. Now I'm putting that back in my brain. Any other questions? So Hal has another question. If Einstein had access to Excel or to database technologies, how much sooner or further might he have taken general relativity? I mean, do you think that people have taken general relativity a lot farther than what? I mean, it feels like everyone is continuing to confirm things that Einstein predicted 100 years ago.
Yeah. I think that's what I think would be more interesting is, would he have accepted quantum mechanics?
He would have to, because it's just so well supported by evidence.
But like if the only thing you changed is when computers were developed, so Einstein in the 1930s, but with Excel, and that's the only
Yeah.
variable we're changing, would he have become someone who did research in quantum mechanics?
Yeah, I don't know.
I don't know either.
All right, those are all the questions that I've see. Have you been watching Andor?
I have one more episode of the
Me
season
too.
left.
Me too. So that's good. Yeah, I'm waiting for Carla to get back, and we're going to watch the finale together. I hear it's terrific, though.
Yeah,
I mean, is Andor the best
yes,
Star Wars thing that's ever been done?
I think so.
I think so too.
I haven't seen Kenobi yet, but I
Nah,
haven't
it's fine.
seen
Like,
there.
like, like Kenobi, Mandalorian, the Boba Fett one. They're
I
all.
haven't seen that one yet either. I've seen
It's the worst of
Mandalorian,
them. Yeah, the Mandalorian. It's fine. Like, who doesn't love Baby Yoda?
right?
But
The
Andor just felt real, and it was the Star Wars universe that you felt in the first movie and the second movie. It felt great.
yeah,
Yeah. And someone saying, well, they're doing anything, Rogue One was great. Yeah, I watched Rogue One. I went back and watched Rogue One because the characters in Andor show up in Rogue One.
yeah,
And it was fantastic again. Like, you just watch it again, you're like, that is so good. And they've stitched together the two. But yeah, Andor is so good. So good. Like, it is redeemed Star Wars in my mind.
yeah. There was one tweet I saw that I think summed it up really well. Episodes 1 and 2, this is good. 3 and 4, this is getting more interesting. And then it's like, Star Wars! And that's pretty much, it sneaks up on you, and then like you're unable, it is unable to let go of you.
Yeah.
I have apparently woken the dog with my enthusiasm. Hi there. Did I frighten you?
That's something I can't do. I can't wake up my dog,
It's true.
my deaf dog. Yeah, so good. So good. Just like every part of it. Andy Serkis,
Yes.
the whole stuff, all the stuff in the penal colony. It's all so good.
Yeah.
Yeah.
And
Yeah, that, like, if they could have him direct everything now,
yes.
it'd be great. What else? No one else has any questions. All right, I think we need to wrap things up then, because I got to get
Okay.
into this other meeting. So why don't we shut things down? So,
All right.
thank you everyone for joining us today. Thank you, Pamela, for bringing the brain. Thanks to I guess everyone watching us on YouTube. Thanks to our moderators. Although it doesn't look like you were too busy, which is good.
That is good, yes.
What's coming up next?
We are doing. So we realized that recording a show called The Daily Space that only aired on Saturday and Sunday was kind of dumb. So we're doing some restructuring, and we're going to be releasing a new show called Escape Velocity Space News that we're putting together the logos and everything this week. And so, yeah, just basically doing rebranding. Our brand name is Lies.
It's on Daily Space. Yeah, you tried to do Daily Space. Our new video hit the YouTube trending page.
That is
which was
cool.
Yeah,
That is very cool.
Yeah, I mean, we got 300,000 views on the video over the weekend, which was pretty amazing.
That's amazing.
But it also just like dragged out all of the flat earthers and science deniers and so on. And it's just like, it's just this low grade. It's hard to describe. I mean, you know what I'm talking about.
I do.
Just this negative hum that seeps in your soul.
These are the things that make you lose faith in humanity.
They absolutely do. Yeah, and you're just like, even though it's like whatever 97% liked, it's just like there's just these people who are just so mean in this just passive aggressive superior way that just makes you Yeah, it just saps the wind out of your sails. But anyway, we're number one. We're not number one, but we did great. And then the next thing is we did obviously the 200th QA with all of the Avengers Assemble, all of our special guest stars.
That's
You should
awesome.
definitely check that out. And we've got the next QA is going to come out in a couple of days as well. So, and of course, my live show tonight at 5:00. So come join me, ask more Lagrange point questions. I'm ready. All right, Pamela, thanks a lot. And
All right.
we'll see all of you next week.
Okay. Bye-bye, everyone.